Hi, my name is Mary Beth Lee, and I'm an Intel analyst at the Vertex project. For today's demo, we're going to go through how you can use Synapse to help you investigate a phishing email. We'll pretend that a partnering organization identified a phishing email they passed along to us, asked us if we'd be able to take a look, and then share our findings back with them. So I'm going to fork a view, and forking a view is going to give me a scratch space in which I can do all my work. I still have visibility into all of the data and the annotations and the underlying production level. However, all of the changes that I make during the course of my research, whether it's adding data or annotating data, those are all going to stay contained within my forked view. At the end of my investigation, I can go through and I can review all those changes, fix any mistakes that I may have made, and then if I want to keep the data, I can go ahead and I can merge my view down into the production level view. However, if I decide that I don't want to keep that data, I can always just delete the view entirely. If I do want to keep the data, but I'm not ready to merge it yet, I can always just keep it within the view. We'll name this view Fish, since that's what we're working on, and we'll create it. So right now we're in our new forked view, and I'm going to lift the file that our partnering organization shared with us. So when they shared this file with us, we uploaded it to our Synapse instance, the Bytes went into an axon, and then Synapse created a file Bytes node to represent the file for us. So this is the file Bytes node. One of the first things that you'll notice is that it's orange, and that's due to a tag that you can see on the right here, this VTX MDR 2021-902 tag. If we hover over it, we can see that it means that this node is related to MDR Client Support Ticket 2021-902. We use tags for a couple different reasons within Synapse. One of them is, like we're doing in this instance, as a way to organize or label data. For example, everything that's related to a specific client support ticket or an IR engagement will get tagged with that specific ticket number or IR engagement number. We'll also use tags as a way to keep track of assessments that either we made or a third party made. For example, if we decide that some nodes are malicious, we'll tag them with cno.mal. If we decide that they're related to a cluster of threat activity, we'll tag them with cno.threat. Whatever the identifier for that cluster is. Similarly, if FireEye comes out with a report with hashes that they've attributed to Ibd28, we'll tag the nodes representing those hashes with rep.fireeye.ibd28. Tags are a way for us to provide additional context to the nodes that we have within Synapse. And this will help us later if we're doing an investigation or any sort of research and then we re-encounter that data. We can use the tags to identify what our assessments were, whether we worked with this data before as part of a client support ticket or an IR engagement, or whether somebody, a third party like FireEye, reported on these nodes and what their assessment was. Now, because we haven't done any sort of processing of this file Bytes node, we really just uploaded it and tagged it. There's not a lot that's connected to it within our Cortex. If we go over to our Explore button on the side and we try to pivot out to adjacent nodes within the Cortex, we really just see the different hash values for that file Bytes node, and then we see the file base node that represents the name. There's really not that much here. So what we're going to want to do is run a tool that we have called the file parser. This is going to go and it's going to run through the file and it's going to parse out all of the indicators and then model them within Synapse. And we can run this file parser through something called node actions, which you just click, go to actions, file parser, and parse. So the file parser created 170 edits on 31 nodes. We can see one of the edits right here. It identified the MIME type, knew that this was a message. And to see the others, we'll go ahead and hit that Explore button again. So over on the right-hand side at the top, we can see that there's 28 nodes here now. We can use the scroll to form tool to help get an overview of what those different forms are. The one that I'm specifically interested in is this INET email message node. This is representing the email that was parsed out from this file. So our email is here at the bottom. If we click on it, we can see it in the side in this details pane. So this is the email that our partnering organization identified and shared with us. We can see the recipient was this bankpost.ro, so we'll want to check to see if we have any information about that email or any organization associated with that domain name. We can see the subject matter as notice, we can see the sender email, and we can see the date it was sent. We have the bytes of the email itself, and then we also have the body of the email, which when we hover over it, we can actually see that in a little pop-up window. We can see that mentions the single euro payments area, SEPA zone, and then it has this sepacloud.eu URL in here. So we're going to hit the Explore button and pivot off of this INET email message node. And so we're going to look at the recipient first. because I want to see, there's the bankpost.ro domain, which sounds like it's a bank in Romania, but we'll see if we know what this email is associated with. So let's pivot off of there. We can see the user, the domain. Let's try to pivot off of the domain. So one of the nodes that we have here affiliated with that domain is an OU org node for Bankpost. Bankpost is based in Romania, it looks like. And if we hover over the description, we can see it was a Romanian bank that has since merged with Bank of Transylvania. So we know that this email was sent to a recipient at a bank in Romania that's now merged. And if we walk back on our breadcrumbs up here, we can see the other details from the email. One of them that I'm interested in is this INET email message link. This is the node that connects the URL that was contained within the body of the email to the email itself. So we'll explore out from this node and see if we can get to the URL. So one of the things that we notice here is that the URL is in bright blue. And I know that this means that it has a specific tag on it because this is something that I set in my workspace settings. You notice that our original file that we started out with was orange and that this one is blue. I like to apply color code to certain tags as a way to help them catch my attention. So therefore, when I'm re-encountering that data, I know that this is something that we've already processed, that we've tagged with a certain tag, and it's something I should take a look at. So we'll go ahead and we'll walk back a little bit and we'll go back to the original email. So at this point, I might want to go back through and pull in some additional data about some of the indicators that I have. For example, the cipacloud.eu domain, I might want to see if there's a whois record or DNS or PDNS data, or maybe I can even query VirusTotal to see if there's any files that are downloaded from this domain or communicate with it. This data is all something that I'm able to import and model within Synapse through something that we have called power-ups. Power-ups are basically connectors to external data resources, and I can run them through node actions, which is the same way that I use to run the file parser. So if I decide that I want to enrich my Synapse instance with additional information about this domain, I can click on it, go to actions, and I'll get a list of all of the power-ups that are capable of providing additional information for a domain. For example, I might go to NetTools and pull in DNS data. I might go to whois and see if I can get a whois record. And I might go to maybe VirusTotal and see if there's any communicating files for this domain. And those will run, they'll update my Synapse instance with that additional data that they'll model for me. And then I would be able to use the Explore button to go and pivot out and find that additional data. So now if we walk back to some of the other indicators that we were able to parse out from that original file containing the email, one of them that we'll want to take a look at are the IP addresses. And we have one that was bright pink, so I wanted to make sure that we got back and checked it out. When we click on it, we can see that there are two tags. One of them is cnottbfish.source, which if we hover over it, we can see that means that this IP address is actually an originating IP address that was used to send a phishing email. Another one is threat.sundance.use, so different from own. If we hover over it, we'll see that this means that it was an indicator that we saw used by Sundance threat cluster, but it's not inherently malicious itself, and it's probably not unique to that threat. So that's why it's a little bit different color coding than the bright blue that I use for the threat Sundance.own tag. If I wanted to bring in some additional information about this IP address, for example, DNSA records or files that communicate with it, I could do so through running power-ups. Power-ups are basically connectors to external data resources that will allow us to bring in external data and it will model it for us in Synapse. I run power-ups the same way that I ran the file parser, which is through that node actions command, where you click on the node, you go down to actions, and then I'll get a list of all of the power-ups that are capable of enriching this INET IPv4 node. For example, if I wanted to run MaxMind, I could go ahead and just click on it and it will run. I'll update with some information. If I wanted to maybe go to NetTools and see if we can pull in some DNSA records, it'll go ahead and run. It looks like we have the most recent records. And then I can always go and click on the Explore button to go and then explore out and find that data where it was modeled in the Cortex. So this one, we're particularly interested in seeing if there's a phishing email that was related to it, because we know that it was identified as, or we assessed that it was a source of another phishing email. So when we pivot out, we'll see this is the file that we're currently working on, but then we see this other one that again is in bright blue. When we click on it, we can see on the side that it has two tags that are the blue ones, the CNO-mal and CNO-threat-sundance.own. It's also noted as a phishing email, and it looks like it was also something that VirusTotal said was an email. So let's go pivot off of this and see if we can get to the INET email message node. And we'll go up to scroll to form to make our job a little easier and go to the INET email message. We can click on it so we can see on the details on the side. And so we can see that it was sent to a Bolivina at nsbank.ru, which also sounds like a bank, similar to our last recipient. It was sent by Dennis at intercasa.com. We can see the date, we can see the actual bytes of the file, and then we can hover over the body to see the contents of the email. And it looks like there is download Outlook. It looks like there are two URLs, one download Outlook and one SNIPA Europa. So at this point, let's pretend that we've gone through and we've done all of our research and we've decided that this is a phishing email that we're looking at, and it's also a phishing email that we're going to attribute to the Sundance threat cluster. So at this point, I'd want to apply some tags to make sure that we're able to capture that context. There's a few things that I want to tag. The first is I'd want to tag the email message itself and note that that's a phishing email. I'll do that by applying a cno-ttp phish.email tag. But I'm also going to want to tag the recipient email to note that they were the target. I'll want to apply a tag to the sender to note that they were the sender email. And I'll also want to apply a tag to the URL to note that it was the payload. So these are a lot of tags to apply, and I don't want to do them by hand. So what I'm actually going to do is use some automation that we have. We support two types of automation within Synapse. One of them is a cron, which is time-based automation. We also support triggers, which are event-based, and we're going to use a trigger in this case. So we'll go over to my admin panel, and we'll go to the triggers. And the one I'm going to use is this one here that's going to propagate tags for me. And I'll switch it to my view. So we'll switch to my fish view. So what this trigger is going to do is going to push tags from the email message itself to all the different components. When I tag the INET email message node with cno-ttp phish.email, it's going to actually launch this trigger, and this trigger will go through and it will tag the sender as the sender email as the sender for this phish. It'll tag the recipient email as the target. If there were an attachment, it would go ahead and tag the file bytes of the attachment as the payload. However, we just have a URL, which will go ahead and tag that as a payload instead. So we'll save this so it can run. And then we'll go back to our research tool. And so I'm going to apply the tag on the INET email message node that will kick this off, cno-ttp phish.email. So we'll apply the tag. And so you can see that 4 edits were made. So you can see 4 edits were made. We saw that the node changed colors to pink, and the tag is right here. So let's go see if the rest of the tags applied. We hit the explore button, and we can see that the recipient was tagged as the target. The sender was tagged as the sender. And let's go check that INET email message link. And the URL was tagged as the payload. So our trigger ran ahead and it applied those tags for us so that we only had to apply one. And it looks like it ran pretty smoothly. So everything that we've done so far has been in what we call tabular mode, where data is displayed in table-like format. However, there's different modes that you can use depending on what you're working on. For example, if I wanted to see maybe everything that was attributed to that Sundance threat cluster, I could use force graph mode. Let's go ahead and, so everything attributed to Sundance, dance.own. Force graph mode is a really helpful way to identify how things are or are not connected in the cortex. For example, whenever we create a threat cluster, we want to make sure that the threat cluster is contiguous, that we're able to connect all the dots and show how all that activity is related. When we see our CNO threat Sundance.own cluster, we can see that everything is connected. If I saw a single node out here floating by itself, I would know that something's wrong. Either I need to go and do some more research and identify supporting evidence for why that would be a part of this cluster, or I have to go and untag that node because it's not actually related. A lot of the actions that you do in tabular mode are also things that you can do in force graph mode. For example, if I wanted to see what a specific node was, I can go ahead and I can click on it and I'll see the details on the side. If I wanted to enrich a node with additional data, I can go and I can click on it and go to node actions, and I'll have access to all of the power-ups. If I wanted to pivot out from a node and see what else was connected to it in the graph that maybe wasn't tagged with a specific tag, I can double click on it and I'll be able to lift all of those other nodes. And then if I decide that I actually don't want to do that, I can go to undo here and it will pivot back. So force graph mode is one option that you have. Another mode that we have for visualizing data is our statistics mode. Stats mode is particularly helpful if you're doing any sort of pattern of life analysis. For example, here we've lifted file bytes nodes that FireEye attributed to Ibd28, and we're specifically looking at files that have compile times modeled. If we go down to the table here, we can see that based on what we have in our cortex, that the majority of the files are compiled from basically Monday through Friday, and that Saturday and Sunday were a little bit quieter. That might let us know that this was something that was done during maybe a regular work week. If we scroll down a little bit further, we can get an overview of the time span that these were compiled. Right now it's by day, which might be a little too granular, so we could switch it to month, and we'll get an updated table showing us what the breakdown of that time frame looked like and when they might have been compiling more or compiling a little bit less. The last mode that we have is Geospatial Mode, which is helpful if you're doing any sort of research with geolocation data. Right now, we're just going to lift some Tor exit nodes that we have. We can always click on a node if we want to see what the node is on the side, and we'll have the same node details. We can zoom in, we can zoom out, we can always go and we can change the view. If we decide that we want a satellite view, we can do that as well. All of the different data visualization modes that we have, we can export to a tool that we have called Stories. Stories are Synapse's internal publication tool. For example, this is a story that I might have created to share our findings back with our partnering organization. It supports Markdown so that we're able to pair text along with data that we're able to import directly from Synapse. The big benefit of using Stories is that the big benefit of using Stories is that all of your work lives within Synapse. You don't have to try and export data to a third-party application and then check back and forth to make sure that your data is still representative of what you have in Synapse. With Stories, we're able to match prose along with data. And because the data is imported directly from Synapse, it's fairly trivial to make sure that it's representative of the most up-to-date data that you have in your cortex. For example, these are the two emails that I am reporting on for this story. And if I wanted to make sure that they match what we have as Synapse, I can always go to the tool on the side, I can refresh the nodes, or I can even refresh the query that I use to pull the nodes. For example, these are two emails that I was reporting on for my story. If I want to make sure that they were representative of the only two emails that we had tagged or attributed to that Sundance threat cluster, I can always go and I can refresh the query to lift any additional nodes that we may have tagged since I started writing. If I want to make sure that the nodes themselves are up to date, that there weren't any changes in, say, any of the fields like the to line or the subject line, I can always go and refresh the nodes and make sure that I'm pulling the most up-to-date information that we have. Stories is highly collaborative, and I can always give access to another member of my team. That person would be able to go over to the comment section. If they are, say, proofreading for me, they'd be able to go and leave me a comment if they notice anything that they suggest that I fix. If I were reviewing this and I was curious about what query someone used to lift data or where that data came from, I can always go to the menu on the side and I can copy the query. That will copy the query that they used to my clipboard, and then I could go ahead and run that query back in the research tool and see what query they were using, what question they're asking, and then what data they were able to get from that. And that would allow me to provide them some better feedback because I'd be able to do a more informed review of their work. Finally, if I am ready to share my story, we can switch it back into preview mode. If I'm ready to share my story and I'd like to share it internally, I can do so by going over to the menu on the side, going to story settings, and I can always give a user permission. In this case, I gave our Aussie user permission as a viewer. If I trusted this user a little bit more, they could have editor permissions or even admin permissions. If I wanted to share my story with someone who did not have access to my Synapse instance, I could do so by exporting the story as a PDF. We have a little export tool on the side, and it will generate the story as a PDF that I would then be able to save or print if I wanted to and share it with them. Stories can be as formal or informal as you want. We also have other ways that you can share data. For example, if we go back over to our tabular view, and let's say that I wanted to share all of the data that we had attributed to the Sundance threat cluster, I could always lift the nodes, and then I could go over to the side here, and if I was sharing with somebody who had access to a Synapse instance, I could export the nodes files themselves, specify what tags I wanted to include, and then export them. If I received a nodes file from someone, I could always go up to my menu here and import the nodes file, and then I would have the same nodes that that person had on their Cortex that they shared with me. And I would have the same tags that they included. That would download a nodes file, and then the person who received the nodes file would be able to go over to their menu on the side. They'd be able to import the nodes file, and they would have the same nodes that I'd shared with them along with the tags that I had included. If I wanted to share data with somebody who did not have access to a Synapse instance, like let's say I wanted to share these 16 file Bytes nodes, I could always lift the data and I could go over and export it as a CSV, and this would be a way for me to share structured information with them. However, if I wanted to share data with someone who did not have access to a Synapse instance, like let's say, for example, that I wanted to share these 16 file Bytes nodes with someone, I could always go over to the menu on the side here, the hamburger menu, and I could export the data as a CSV, and then I'll have structured data that I'm able to share with them. The recipient would be able to take that CSV and upload it to whatever tool they're using. So at this point, I've done my investigation, I've tagged my nodes, and I've shared my findings, whether it was in the form of a story, a nodes file, or a CSV. If I want to keep the data in my view, I can go ahead and I can merge it down to the underlying view. However, if I decide that I don't want to keep the data, I can go ahead and I can just delete my view.